I had mentioned when we talked about this step, setting the equation equal to 0, I'd mentioned that sometimes that's a little tricky, and this is an example. And it looks like, oh great, the left-hand side's factored. Well, the left-hand side is multiplication. The problem is the right-hand side isn't 0. So what we need to do is we need to multiply this out. So I'm going to use FOIL, 2m squared, because it's a binomial times a binomial. And then I'm going to have 6m, and I'm going to have 1m plus 3 equals 12m. Now I can simplify the left-hand side, 2m squared plus 7m plus 3 equals 12m. Now I can set it to 0. Now I'm going to subtract the 12m from both sides. Now when I do that, I line up those like terms. It's the m terms that are going to get combined. So I'm going to get 2m squared minus 5m plus 3 equals 0. Now it's set to 0. So it was a little bit of work, and sometimes it's confusing because on the left it's like factored, so you're thinking, oh, it can be like the very first problem, but it's not because it's not set to 0. So now if you're asking, well, could I have moved the 12m over first? You could. That would be okay to do, but you're still going to have to multiply out the binomials. So I just wait. It seems to write a little bit easier, but that's up to you. All right, we're not done. Now we have to factor the polynomial. So this one doesn't look too bad. Maybe I better use the AC method. It's always good to go over the AC method several times, so till we get it. So we need two numbers that multiply to be 6 and add to be -5. And while those numbers aren't super large numbers, this is one of the sticky ones. So you only have two choices for 6. It's either 1 times 6 or 2 times 3. But it has to do with the signs. It's a positive 6 that we're multiplying, and we're trying to get a -5, so both signs have to be negative. If you put them here, you get a -7. If you put them here, you get a -5. So people often get this one wrong because 1 and 6, if you just subtract them, you get 5. So this is a little tricky, even though there's two numbers. Okay, but those are the two numbers we want, -2 and -3. So we're going to write 2m squared, keep the first term, minus 2m minus 3m. And by the way, it doesn't matter which one you write first. If you wanted to write the minus 3m first, you could. I just usually write them in the order that they are. All right, here comes my dotted line. So I look for greatest common factor in the first two terms, 2m, and I get m minus 1. Okay, now you can double check that by multiplying here. Is that 2m squared? Is that minus 2m? It is. Okay, then behind the orange dotted line, we're going to factor out a negative because of that sign right there, and it'll be a 3, a -3. So that's going to make it m. Now, because I factored out the negative, it changes the sign here to -1. So again, you could check that. Is that -3m? Yes. Is that +3? Yes. Okay. So far so good. And then you look to see if that binomial, the binomial here, is that the same as the binomial here? And it is. Yay! That means our grouping worked and life is good. Okay, so one of our factors is m minus 1. The other factor is 2m minus 3. Now, and this all equals 0. If you want to write the 2m minus 3 first, you can. Multiplication is commutative. Okay, so finally, we got it set to 0. We got the polynomial factored, and now we can say either m minus 1 equals 0 or 2m minus 3 equals 0. All right, so solve each linear equation, add 1 to both sides, and so we have 1 as an answer. Here we're going to add 3 to both sides, 2m equals 3, divide by 2, And so m equals 3 over 2. We're going to leave those as improper fractions, by the way. So when you get a fraction, don't think to change it to a mixed number. We're going to leave it as an improper fraction, unless it's a word problem where it makes more sense to put it as a mixed number. But for the most part, for us, we're going to just leave them improper. So I get a solution, two solutions, 1 and 3 over 2. So these are pretty fun.